as regulars will know, I normally drink local beers, or at least Canadian beers, when I'm down here tinkering away in my shop. But I'm going to make an exception because my buddy Brad from the Canned Wine Podcast was visiting and brought me a few from the States, such as this Mermaid Pilsner from Coney Island Brewing. Doesn't say anything about it other than the fact that it's a Pilsner, and we can see that it's pretty light, so let's give it a try anyway. Yep, definitely a hoppy Pilsner. Anyway, that's not the main focus. Today, we're taking a closer look at this, well, it doesn't really say much about it there. It's a 10-watt DMX Lite. This is the little cheap spotlight that I got in my mailbag a couple of weeks ago. As you can see, it's not very huge. Has a basic 2-prong cord on it, not fully compliant with North American standards, but it'll be close enough to do the job for now anyway. It came with this product catalog. It's from the Sheds company, by the way, who are makers of relatively inexpensive stage lighting. This one is a super cheap one, way at the bottom of their line. A lot of their stuff is slowly moving up into the slightly more professional grade, although, I mean, it's still all plastic, and it's still affordable compared to any of the major brands of stage lighting for stuff like these. But anyway, I bought this, as you saw in the mailbag, and it was super cheap. Let's just go for a quick refresher on the website. So I got mine on AliExpress for, well, right now it's selling for $27.99 plus some shipping. But I think it was a little bit cheaper when I bought it, something like $25 or something on sale. Regardless, that is super cheap for this thing, especially considering the MSRP is over $70 Canadian. Might as well look at it on their website rather than AliExpress. There's the back of it. We'll look closer at that in a minute. One thing I've noticed on their website is they do have manuals for some of their products, but not the super cheap stuff, and this one is no exception. So no manual came with it, no manual on the website. I just had to do some tinkering and experimenting and guesswork to figure out what's going on. Anyway, when used in groups, they kind of look like that. Single one, like I've got some ideas for what it might be used for. Anyway, let's get back to reality here. So there is the back of it. There's the fan, and it looks like it's got a little bit of a foamy filter on there, so that's a nice touch. 3-pin DMX in and out, not compliant with the perfect standard, the full standard, which shows 5 pins, but 3-pin is increasingly common, especially with cheap lights. So whatever, we'll let them get away with that, I guess. Very typical menu, up, down, and enter keys on the back. There's a little cable gland on the bottom, a straining leaf you might call it. And then there is the lens up front, and I'm not sure if you can see, if we sort of zoom down inside, you can see 4 LEDs in there, which will be the red, green, blue, and white. So let's fire this thing up and just see what kind of power it draws. It claims to be 10 watts. I'm just going to put it into manual mode here, which, as I think you can see, maybe you can't. There, if I change the camera settings a bit, you can see that there are the 4 LEDs being projected out the front. Now, the further back you get, the more they blend together into a single spot. Although, since they're not perfectly aligned in the center of the lens, you can see that they're not overlapping 100% there. But if you're using the colors one at a time, it's not a big deal, I guess. Anyway, through the PWM, you can see that the red is set to 255, the green is set to 255, so is the blue, and so is the white, which should be the maximum power that this thing draws, and it's showing 6.7, 6.8 watts. So much less than the 10 watts that they claim. Still, it does throw a fair bit of light in a small area. Let's just look at the menu here quickly, if you can see it. Yeah, this is going to be difficult to read with the PWM interfering with the camera. Anyway, the first menu item is the address. The second menu item is going through the 4 colors in manual mode. And as we saw before, that's putting them out there so we can set each of them in manual mode. Next is a flashing mode. Currently it's flashing at a rate of 40. That's not interfering too bad with the camera. And that is flashing all 4 LEDs at whatever the previous menu settings were, the RGB and W. So you can tune that to do any of those. And the next is just a color mode, and there's that easier to see. So that's color 1, 2, 3, 4. So that's 4 of them individually. Color 5 is all of them together. 6 is those 2, 7 is those 2, etc., etc., all the way up to number 12, and then back to number 1 again. Next is CC, which is color change. And again, the speed is just the speed at which it cycles through all the colors like that. Next is DE, which I'm not quite sure what that stands for, but what it does is that just slowly fades through the various color combinations. And again, you can set the speed of that. And then CP, which is another timed color change, but this one, instead of flicking through the colors, it is slowly fading through them, which may actually be a more artistic thing to just leave sitting on in the background or something like that. And then you have sound to light mode, which is a sensitivity which you can adjust. I can't talk loud enough. Well, I can talk loud enough to make it happen, but then I'll be screaming in your ears. So I'll just tap on it. I'm not quite sure where the microphone is, but you can see as it gets a kick of sound, it just goes through its various colors again. Useful for an unattended disco mode, I guess. And then we go back to the address. I'm not sure what the difference between D and A is, but they both seem to be some variant on the DMX address. And as DMX is a 512 channel protocol, that can be set to any channel between 1 and 512. I'm just going to leave it set at 1. So its functions are going to start at 1 and go up to the maximum number of functions this thing has, which I think is 5 or 6. The 4 lights, the 4 different colors, and then 1 or 2 flashing modes, I think. I don't know. Well, let's play with it. Oh yeah, and with it just sitting idling with no light on, it's drawing 0.7, 0.8 watts in standby. So that's basically just the fan and the power supply, I guess. So we'll plug the DMX into this, and not sure whether you can see it. Yeah, you can see it flashing down there to indicate that it's receiving some DMX data. I know we saw this before in the mailbag, but I'll just run through it quickly. So fader 1 appears to do nothing, but I think that's just a master. Number 2 is red. Number 3 is green. Number 4 is blue. Number 5 is white. And 6 controls the speed of a flash. Seven seems to fade through those other things. Let's just clear that again, and yeah, so depending on, oh no, that is auto fading, so 7 controls the speed of that auto fading, right? What does 8 do? Doesn't appear to do anything. When I turn these guys on, does it affect them? No. Okay, so it looks like it's just got 7 channels, or if it does have 8, then I can't figure out what number 8 does. Anyway, that's DMX, and that is really handy for remotely controlling it. You can combine it with other lights, etc., etc. Right, that's enough of that. Teardown time. So it looks like we've got 1, 2, 3, 4, 5 screws to take the front off. And I think I will get this cheap little stand out of the way, or hanger bracket, or whatever you want to call it. It is really, really flimsy metal. But this thing's pretty light too, so I don't think that is a problem. So let's see what's behind these. Okay. So it looks like we have the power supply board on the front and all the brains on the back. Let's just unplug the power supply from the rest of it so we can take a closer look. All right, so there is the board out. We have mains coming in here. We have a fuse there. F2A 250 volts, 2 amps, okay. And then we have an optocoupler, capacitor across there, another capacitor and a diode there. Presumably that's the DC output. On the back side we have a bridge rectifier, which, yeah, that comes from the line and the neutral through there. So that goes to there. One side goes way over here to the transformer. The other side looks like it goes, okay, that's also transformer there. Where do these center taps go? They go to this little chip over here, which is FSD 6208A. After doing a bit of searching, I cannot find a data sheet for that guy, but we know it's going to be a power supply chip, don't we? Probably has a MOSFET built into it to chop the DC voltage up into a higher frequency to push through the transformer. There is our gap there. That little blue guy is pretending to be a protection capacitor. I can't tell what class it is from the markings because I can't see them. Anyway, regardless, that and the optocoupler are straddling the gap. Reasonable size gap too. Then on the output side, the secondary side of that transformer over here, we have a small diode and a resistor. Those guys will be, yeah, those guys are both in the path of the LED side of the optocoupler. And then we have the big diode and the big capacitor on the output, and then outputting to there. 1000 microfarad 16 volt capacitor on the secondary side, on the DC output side. So I'm going to guess that this is probably a 12 volt power supply. Yes, it is. Although weirdly, it is a reverse voltage. The black wire is the positive side. So be it. Let's set that aside and take a look at the brains of the operation over here. So you can see the lens, the interior lens. There is also an exterior lens on there. This lens is supposed to be focusing all of those guys down on to the output, and that's funky. They are using self-tapping screws into the plastic, but then they are using a nut as a spacer. That's wild on both sides. That is cheesy, but I guess you do what you got to do. Anyway, there is the RGBW LED. One pair of leads for each of the 4 chips in there. And those guys all disappeared down onto the main board here. Let me just unplug some of these guys. They don't look like they are held in by anything other than just the friction of the connector and its locking tab, such as it is. So some of these things that I've taken apart have glue on them. This isn't one of them. In addition to the wires going up to the LED and the wires going back to the buttons on the control panel, that's these 4 black ones. There's also this 2-wire here, which is going to the fan. So down here by the connectors, we have 4 inductors, we have 4 diodes, and we have 4 MOSFETs and 4 pull-down resistors. So that will be driving those LEDs clearly. Over here we have a microphone, but it doesn't have any holes in the case or anything, so the sound sensitivity is just going to have to be reverberating through the case. I suppose if you really wanted to use it in sound mode, you could drill a hole in the side of it. I don't know. Anyway, we have the 3 pins of each of the DMX connectors. And a couple of chips. What is that guy over there? 7805. That is a 5 volt regulator, so knocking the 12 volts down to 5 volts, presumably to power these chips here. Let's see if we can figure out what those guys are. BL3085 is a little 8-pin jobby. That is an RS-485 transceiver, which makes perfect sense because DMX512 is based on the RS-485 protocol. Which leaves the brains of the operation, which I suppose is probably that guy. Nuvatron MS51F9 FB9AE. Right. Of course it's a microcontroller. What else would it be? It is a 24 megahertz 16K flash, 1K SRAM, 4K bootloader, equipped with UART and I2C and SPI and 18 GPIOs and a bunch of ADCs and a whole bunch of stuff. So we can guess that one of those UART inputs is being used to process or to receive the DMX signal from that RS-485 interface. We can also guess that one of those channels of ADC is being used to monitor that microphone. 4 more of those GPIOs are being used to drive the MOSFETs that drive the LEDs, and a handful of the GPIO is going to be used for the buttons and the display on the back. Although since that's a 4-wire, it might be using either the I2C or the SPI to talk to those. Maybe we should look a little closer. And I'm going to guess that that is one of its UART inputs or I2C or one of those programming inputs there to reprogram the thing. I am not going to get that deep. I'm not going to go into the SDC and try and learn how to program this chip. I have far more programming that I'd rather do on other things, and I don't like programming all that much. I'm going to guess that the screws holding these XLR connectors on are probably the screws that are holding the whole board into the case. So we'll just hoik those out and see if there's anything of interest on the back of the board. A little bit of a trick getting it out past that, but okay, so there's nothing on the back of that board. There is the button and LED board, and we can see on there we have VCC minus clock and data. So that sounds an awful lot like I2C, doesn't it? I bet it is. And there is that board with 4 buttons and 4 digits of 7-segment LED and one little chip on there. ET6226M. The datasheet was, of course, 100% in Chinese, so I got Google to translate it for me, and it is a job-specific LED drive control and keyboard scanning ASIC, application-specific IC. So it can control 4 8-segment LEDs, so that's a 7-segment plus the decimal point. The brightness control provided. Oh, that's cool. Keyboard scanning, keyboard 7 buttons by 4-bit high-speed 2-wire serial interface. Built-in clock oscillator, power on, 3 to 5 volts. Yeah, we already knew that. So there is a sample schematic, clock data, power and ground. This infrared is something else. We won't worry about that. There is the 7 segments and decimal point. There is the 7 buttons. Pretty straightforward little chip, actually. Handy little guy to keep in mind. So now the only challenge is getting it all back together and seeing if it works. So if you excuse me, I will just do that by myself, and I'll come back to you guys to power it on and see if it still works. Okay, we are back together. Let's plug it in and see if it still works. Well, that lights up, that's good. And there is our 4 colors. Cool. Well, that's an interesting thing. It's about what I expected inside based on taking apart a few other cheap LED lights, including another one from that Sheds brand. But anyway, yeah, it's, I don't know, for what did I pay for it? Less than $30. I think it's worth that. I don't think it's worth the $70 that they've got it listed for on their website. But I mentioned before that I think I have an application where this will probably be just about perfect. Well, let me show you. So there is the application that I think this would probably be most suited for. Not necessarily a professional mode, but more like a dorm room disco or basement bar atmosphere lighting or something like that. So these are just slightly less than a meter apart between the mirror ball and the light. And this mirror ball is actually, where'd the box go? It's actually a pen holder from the dollar store. Tiny little thing too. You can see the size of the box compared to my hand. But anyway, yeah, I think that would probably, let me just aim that a little bit better. There we go. Give that a little bit of a spin. Woohoo, disco mode. Well, thanks for watching. I hope you found that interesting or informative or entertaining or a good way to waste half an hour. What is this, 20 minutes, something like that? Anyway, thanks for watching. I do appreciate that. Questions or comments down below. We're down there. As usual, I will talk to you later.